Great. So let's kick it off. So good morning, good afternoon, good evening, everybody, wherever you're located. My name's Todd, and on behalf of Kubeshark, I want to thank you all for attending today's webinar. To kick things off, we'll do a few introductions of the Kubeshark team, and then we'll kick off from there. So my name's Todd. I'm on the go-to-market team. With me is Brandon Beisch on the customer success team. And our presenter today is Alon Gramansky, CEO and co-founder based in the Bay Area. To kind of frame up the agenda, we're going to talk about some of the challenges with observability and troubleshooting for K8s clusters. And then we'll go through an in-depth demo with some Q&A in between a couple of segments. And then we'll have a wrap-up Q&A the last 12 minutes of the session. Other items, we have 2 polling questions that will launch shortly and kind of get some engagement and some information from you folks. And then we are recording this session, so we'll be able to send it out so you can share it with your colleagues and so forth. So with that, let me before we get into the first, let me launch the first polling question before we get into the fun stuff. So,
hi everyone, I'm Alon Gramansky, co-founder and CEO of Kubeshark. Today, I'm here to talk about deep network observability and why it's crucial for protecting your business-critical applications. I'm sure most of you are aware, Kubernetes is often used as the infrastructure for hosting business-critical applications. For example, you don't see many clusters hosting email servers or ERP servers. Kubernetes network carries APIs and data that make up the app's business logic. Because of its massive distributed nature, the network can quickly become a blind spot. This can cause SREs and DevOps to miss out on very important insights that can be indispensable to managing these applications in terms of performance, security, and overall reliability. If you're a DevOps or an SRE and you're in charge of protecting your organization's most important assets, harnessing the power of the network should be a must-have capability. Here's the kind of information you can get from the network. Connectivity between pods, services, namespaces, and external services, both expected and also unexpected. Data in flux, you can see data as it flows between the various pods and ensure its integrity, a task that can be crucial for the consistency of your application's business logic. You can ensure your APIs are adhering to their specs. Sometimes reality is different than theory, and detect any security threats, performance issues, and bugs with evidence lurking in the network. By being able to observe the network, you can understand how data flows and how microservices communicate. You can monitor traffic and detect events that might signal a failure. Once detected, these events can trigger remediation actions. Let's talk about how it's done today. Most of you have probably used Wireshark or at least heard of it. It's a fantastic tool. It was built for a time when we used to manage just a few servers with easy access. Here's an example of how can one observe traffic in Kubernetes today. To get the traffic, you need to SSH into a pod or use kubectl. Start traffic capturing using one of the available tools like TCP dump or ksnif. Presumably, you've installed it prior in the pod. Copy the file to where you have Wireshark and use Wireshark to analyze the file. This is, of course, time-consuming manual operation, and it does have some drawbacks. Firstly, scale. An average user manages around 5,000 pods. With your clusters, you could easily find yourself managing hundreds of nodes and thousands of pods. These pods are dynamically launched and terminated. Pod and service identities aren't available on the network. Only IPs are available, and IPs can change, and they mean very little. Lastly, it's quite challenging to view TLS traffic these days. Introducing Kubeshark. We built Kubeshark to enable DevOps, SREs, and developers to see with their own eyes what's happening in every corner of their Kubernetes cluster. Think of it as Wireshark reinvented for Kubernetes. It delivers real-time, cluster-wide API traffic visibility with support to most modern protocols such as HTTP, DNS, Kafka, GraphQL, Redis, AMQP, HTTP2, WebSocket, and more. It works 100% on-prem or on-premises, and absolutely no data leaves the cluster. Kubeshark has several components that work together to provide its functionality. It monitors three different sources. One, Kubernetes via the Kubernetes API to monitor Kubernetes-related events. Two, Linux kernel using eBPF to monitor operating system events. And of course, the network interface to get all the traffic that it carries. As I said, Kubeshark uses different technologies like eBPF, AF packet, and more to capture and process all traffic everywhere and at all times. It also correlates related operating system events as well as Kubernetes events, so you can have the full picture of what's happening on the network. In the next few minutes, and as time permits, we'll talk about a few basic and a few advanced topics related to network observability. After covering the basic topics and before moving to the advanced topics, we'll have a short Q&A session. In the basic functionality section, we'll cover on-demand usage on small clusters, as well as long-living installations using Helm, and demonstrate Kubeshark's basic functionality. We'll talk about how Kubeshark handles TLS before we move into the final QA session. And as time permits, we'll talk about more sessions, more topics. Let's dive in. Kubeshark supports two main use cases. The first being quickly run Kubeshark on demand to troubleshoot a problem you're dealing with right now. The second use case is to have a long-living deployment of Kubeshark using Helm. For the first part of the demo, I'll show how to install and use Kubeshark on demand. Here in my cluster, I'm using 2-node KAIN cluster, Kubernetes in Docker, that is installed on my laptop. For this demo, I'm going to start a timer. I'm using Homebrew to install Kubeshark. Let's check if the installation was successful. Let's run Kubeshark with Kubeshark tap. That's it. As you can see, it took less than 1 minute to install and run Kubeshark on my cluster. I can now see the traffic that flows across the pods in my small dev test cluster. Moving on to the second use case, where I install Kubeshark using Helm on my 10-node EKS cluster. 160 pods. I'm going to first add the Helm repository. Give me a second. There it goes. Okay, and now I'm going to start Kubeshark. Okay. And let's quickly go and see what's the situation with the pods. As you can see, we have 10 daemon sets creating right now. Before a couple of minutes, there was no relic of Kubeshark. We can go in and see the logs. And I think we are ready to launch it. That was installing Kubeshark on a dev test cluster as well as an EKS cluster. Let's show the basic functionality. Okay, let's launch the dashboard. And here we'll soon see, okay, here we see on the left all of the traffic that goes across all pods, across all nodes in my network. As you can see, this is a pretty busy 160 pods. Seeing traffic in real time can also be a bit overwhelming. Okay. We also have the service map that shows all the connections between the various pod services, etc. But again, seeing all the traffic can be more than what I'm looking for. Having said that, let's look at what data is available here. You see the various protocols, you see ICMP and DNS and HTTP, and basically any other application I have in my cluster. When going deeper into an API entry, I can see the request, I can see the response, I can see the HTTP headers, both request response and the payload, all the way to the payload. I see IPs, I see ports, again, request and response, source and destination. What else? I see the Kubernetes manifests at the time of the API call. That's very important because I can come back 2 weeks later and see what's the state of Kubernetes back then. What was the state at the time of the API call? Things can change. Oops, what's that? Okay, moves good. Okay, let's move on. Now, as said, there can be a lot of a lot of information that I don't really need. Okay, what I'm doing right now is looking for an application I've installed, SockShop, the world's most popular demo application. I can use what we call KFL, but look at it as display filters to filter in only the traffic I care about. In this case, it's SockShop, right? And all the and also remove protocols that currently I don't want to see, like DNS. Okay, the picture is much smaller and clearer right now. I see only traffic I recognize. The service map is much more tolerable. Okay. Let's go even deeper. Let's say I'm looking for traffic of a specific trace or a specific user. I can go deeper, extend my KFL statement to include traffic of a specific user only. You can see here. Let's press apply, refresh maybe the screen. Okay, the traffic I see on the screen is only traffic that is related to this specific user, and I can hone in and go deeper and to find exactly what I'm looking for. Okay, I think that's mostly the basic functionality. Let's see where we go from here. Okay, in the next part, I'll describe and demonstrate how Kubeshark deals with TLS traffic. Kubeshark is able to see the encrypted traffic by using eBPF in one of the containers in the worker's daemon set, specifically the container named tracer. It attaches uprobs to the SSL read and SSL write functions to read the incoming unencrypted response and the outgoing encrypted request in any TLS or SSL connection. It does similar actions in Golang crypto TLS function. Now let's see it in action. Okay, going back to the same dashboard, I'm going to use a KFL filter named TLS to see only the TLS traffic. You can recognize the TLS traffic by this small lock icon that appears. Other than that, the entry looks the same as any other traffic, even clear text. You can see the headers of the request and the response, and you can go all the way to the payload. Moving on, in this next section, I'll demonstrate how to record traffic and analyze the content offline. First, let's discuss why recording is necessary. Traffic is huge. It's very challenging to process and analyze all traffic, especially in real time. Even with real-time streaming capabilities, the culprit may not reveal itself when it's convenient. Kubeshark enables you to record traffic based on a schedule, events, Kubernetes or network events, or certain behavior. You can analyze the traffic at your discretion, and you can also cause the recorded traffic to upload to an immutable data store, for example, AWS S3 or Google GCS, which should make your compliance guys very happy. Let's see this in action. Okay, moving to the dashboard. Let's say first, to explain what you will see here is real-time traffic. Real-time traffic we store for only a few minutes. We go back a bit and look at the entry, we'll see we don't have the information anymore because everything is in memory, everything's on disk or on disk. Therefore, we keep it only for a few minutes. So if we want to retain traffic for a longer period, we use the recording dashboard. You can start any number of recording jobs. Let's start one, give it a name. All right, I can start it based on a schedule or right now. Also, instead of recording everything, I want to record something specific, for example, TLS traffic. So in the same way we've used the KFL earlier, I'm going to use it for the recording and start the recording only for TLS traffic. I won't schedule it to run. I want to run it on demand. Therefore, I'm Xing the time. I'm going to do it for only 1 minute. And that's it. Okay, let's create the recording. Once I press create, the recording will start. Okay, so now the recording has started. I can keep using the dashboard. I can move away. The recording is in the background. To access the content of the recording, I can use the same dashboard. What you see now in front of you is basically the content of the recording only, right? As you can see, until now, only a limited number of entries were recorded. When I press apply again, I see more because it's real-time recording. The content will stay on disk until it expires. I think it was 2,880 minutes for expiration. That's roughly it. Other than that, I can analyze the traffic, see it. It will stay there. I can analyze it on demand. It will stay, as said, for at least 2,880 minutes. That's for recording. Okay. The next topic is about Istio. Kubeshark shows traffic in clusters where Istio is deployed. It can be configured in MTLS strict or permissive or any other mode. You'll still see the traffic in Kubeshark. So a brief explanation of what Istio, for those of you who are unfamiliar. In clusters where Istio is installed, a sidecar container with an Envoy proxy is injected to each and every targeted pod. These proxies act as a network gateway. When MTLS is in strict mode, the proxies encrypt egress traffic and decrypt ingress traffic. jumping to the dashboard. Okay, let's jump to the demo. Let's use the same dashboard. I have an application in my cluster that runs in Istio with MTLS is in strict mode. Let's use the display filter to filter that application. Okay. Okay. Any traffic we'll see right now belongs to the application that runs Istio. It looks the same. We try to make everything look the same. When we go deeper, when we inspect a certain, let's find something interesting, certain API call, we can see the various HTTP headers that are inserted by Istio, by Envoy. Okay, but other than that, you see everything. You see the headers, you see the payload. You see an indication for a sidecar. Okay. That is it for Istio. Okay, the last part will demonstrate actionable network observability or actionable monitoring. Let's discuss what it means. So far, we've talked about deep network observability, focusing mostly on the passive aspect of it. Network observability lets you see what's going on in every corner of your cluster, including how services communicate and how data flows. Kubeshark lets you see data in real time or record it for later analysis. This is great for understanding the application's business logic, seeing how data flows through the cluster, and identifying events that might signal failures. What we haven't talked about is how Kubeshark can help you turn those insights into actions. Kubeshark monitors and inspects every API call. Based on this inspection, it can trigger actions such as sending alerts and exporting data to external systems such as Grafana, Slack, a SOC, and more. Let's see this in action. Okay, let's go back to the dashboard. Let's start the traffic. We have a scripting dashboard that basically we provide hooks for every API call in real time, where you can run a simple JavaScript logic to inspect the API call and then trigger an action, as said. What I'm going to do right now, I'm going to use one of the available demos to build a custom metric and then send it to Prometheus and Grafana. Okay, so let's use this demo. Okay, as you can see, whenever there is a DNS entry, the counter increases by 1. And I'm going to give it a different unique name so we can see it in my Grafana dashboard. Starts from 0, increases by 1 every DNS entry. And yeah, and below you can see that there is a job that every 15 seconds send the custom metric to Prometheus. We use simple cron template. That's it. Let's create the job. Let's create the job and run it. That's it. It runs. Again, we can walk away, close the dashboard, use it or not. Scripts, they run in the background. I just want to make sure that everything's functioning well. Yes. Okay, fantastic. Okay, now let's go to our Grafana dashboard. let's explore and let's see if we can find the newly added metric. It was something with DNS. Yep, it's there, DNS3. Okay, nothing still. Oh, okay, here it is. It was able to send one value. If we give it a few more seconds, probably we'll see a second value being sent. Okay, this is a custom metric that I simply specified a name in the script and gave it a value and then use one of the available actions to send to Prometheus. That's it. Okay. That's it for this demo. Thank you so much.
Questions. First one is, does Kubeshark have any analytic limitations compared to Wireshark? Will I ever need to use Wireshark with Kubeshark?
Very good question. So yeah, definitely. Kubeshark does not here to replace Wireshark. It handles the situation where I want to automate traffic capturing and analysis across hundreds of nodes, thousands of pods, and see the main protocols. However, there are many use cases where I will want to download the pickup or basically store pickup files captured by Kubeshark and use Wireshark to actually view them. And in all likelihood, this will not happen in protocols such as HTTP and Redis, which are more application layer protocols. In all likelihood, Kubeshark will definitely suffice for these protocols. But if you're looking into certain protocols that are not supported by Kubeshark, or there is more information at the L4 layer that Kubeshark does not present, again, Kubeshark enables you to download the pickups and view them. Yeah.